Daily life applications of ordinary differential equations. Let's say the polio drops are delivered to 50,000 children in a district. The rate at which the polio drops are given is directly proportional to the number of children who are not yet given the drops. So by the end of 2 weeks, half of the children have been given the polio drops. How many will have fed by the drops by the end of third week? It is a simple problem in our daily life. And the statement says that there are 50,000 children that need polio drops. So after 2 weeks, half of the children have been given the polio drops, which means that 25,000 children have been given the polio drops. Now the task is that how many children have fed by the drops by the end of third week, which means that after 3 weeks, how many children will have fed by the drops. Solution. It's a typical ordinary differential equation, first order differential equation, where 50 is 50,000 children, let 1 equals to 1,000, so 50 means 50,000 children, and y is the number of children that have been fed by the drops. Now separate the variables here. Bring all the y variables at one side and t variable at another side. So I have 1 over 50 minus y into dy equals to k times dt. If you are still not sure about separable differential equation, go back and see the section separable differential equation. It is exactly the same thing. Take integration on both sides. Integral of 1 over 50 minus y into dy equals to integral of k times dt. Integration of left side equals to minus natural log 50 minus y, and integration of right side is kt plus c. C is an arbitrary constant. Multiply both sides by minus to have plus natural log 50 minus y equals to minus kt plus c. Now you might be confused that if we multiplied it by minus, why we have plus c? There should be minus c. Look, we have discussed it already that it's an arbitrary constant. It doesn't matter whether you change the sign or whether we multiply it or divide it by anything other than 0. Ultimately, it is an arbitrary constant. So we don't interrupt the sign, we just put plus c. Simplify the equation, which equals to 50 minus y equals to e to the minus kt plus c. I applied this logarithmic rule where natural log a equals to b equals to a equals to e to the b, where a is 50 minus y, b is minus kt plus c. A is 50 minus y and b is minus kt plus c. You just apply this rule here. Solve the equation further, where I have c e to the c. So as I said earlier, ultimately it is a constant c. So e to the c is simply c. Solve the equation, which is y equals to 50 minus c times e to the minus kt. Now we're going to find the value of c. It is an arbitrary constant. And then the constant of proportionality, which is k. So from the initial condition, which is y equals to 0, t equals to 0. It is the first initial condition where at t equals to 0, the number of children that have been fed by the drops is 0. So y equals to 0, t equals to 0, y equals to 0, and t equals to 0. Simplify the equation, you will get c equals to 50. That's how I got c equals to 50. From this initial condition, y equals to 25 at t equals to 14. 14 is the number of days in 2 weeks, because the statement says that after 2 weeks, half of the children have been fed by the drops. So 25,000 children have been fed by the drops. Therefore, y equals to 25 and t equals to 14. 14 is the number of days, 14 days. Just put these values here. 25 equals to 50 minus 50 into e to the minus k times 14. Solve the equation further, which equals to e to the minus k times 14 equals to 0.5. Take natural log on both sides, where natural log will cancel with the exponential function. So I left with minus k times 14 equals to minus 0.693. Rearrange the equation. This is my final value for k, which is 0.0495. I got the value of constant c and k. Just put these values here. Now the task is that how many children have been fed by the drops after 3 weeks. The time t is 21 here. 21 is the number of days in 3 weeks. Solve the equation further and you will get y equals to 32.32, which is approximately 33. If 1 equals to 1000, which means that there are 33,000 children that have been fed after 3 weeks. This is my final answer. That was our task. So it's a typical form and your task is to search for any other related problems and apply exactly the same procedure